It's great to see you today. We are delighted to welcome you to another episode of Textile Talks. Textile Talks is brought to you by 4 organizations: Studio Art Quilt Associates, of which I am the executive director; Surface Design Association, the International Quilt Museum, and the Quilt Alliance. As executive director of SAQA, I would like to invite you to join us in July 14th and 15th, for a virtual mini conference called Art in Place. We're going to be hearing from multiple artists from around the world and about how where they live affects the art that they create. 2 of the presentations that I'm particularly looking forward to are our keynote from Carolyn Crump, who lives down in Texas, and a lengthy interview of Yoka Sakita from Japan, whose work I have just fallen in love with ever since I first saw it online when she won a major award at the Tokyo Quilt Festival. We're also going to hear from bird artists from the UK, South Africa, and Australia, and from a group called 20 Perspectives, who are coming to you from multiple countries, talking about how they work together, and a number of other exciting events. So please go to SAQA.com, SAQA.com/artinplace, and register now. Anybody is welcome. We would be delighted to have you join us. So today, we're going to be talking about biomaterials and how they interact with the fibers that we use in our art. And I first heard about new materials when I was reading Textile Fiber Forum magazine, which is produced in Australia. And the editor was talking about using mushrooms, to create a leather-like substance, and how that could be used in clothing and handbags and things like that. And I thought, okay, this is really weird. And then I was watching Stanley Tucci on television doing his tour of food in Italy. And he was talking to a company that was using the waste from making orange juice, taking all that pulp and rind and everything, and making it into a fabric as well. And I thought, okay, this is really interesting. I want to learn more. And so I went looking for information, and it isn't that easy to find. But I finally connected with our guest today, Susanne Goetz, who is a professor at the Fashion Institute of Technology in New York City. And not only does she work with MIT, the Massachusetts Institute of Technology, on how we can use technology in creating things made of fiber, but she said at the Fashion Institute, she teaches a course on designing with emerging materials. And they research different textile materials with her students and look at the sources for different kinds of things such as bacteria and yeast, algae, oysters, mushrooms, and apparently pineapple. So I'm really excited to have Susanne talk to us today about what is happening in this field. And I'm looking forward to learning a lot more. As we go through this presentation, if you have any questions for Susanne, go ahead and put them in either the chat or the Q&A box. I'll be monitoring that, and at the end of the presentation, Susanne will answer your questions. Thank you.
Hi, everybody. I'm really excited to be here today, and I just want to give you a bit of background. I'm actually a textile designer. I'm not a scientist. So I try to break this down for the non-scientists among you that might be wondering about all the news you hear about new materials, biomaterials, but can you get your hands on them? Can you use them? What do they do? Are they like leather? Are they like fabric? So I hope I can clarify that a little bit. And I've heard there are some scientists in this webinar too. So please feel free to chip in the chat or in the Q&A later on.
Yes. Okay. Right.
The last few years have seen a pronounced increase in excitement around biomaterials. Biomaterials, however, remain a very ill-defined category. And what are biofabricated, biosynthetic, or bio-based materials? What do those terms even mean? Are they all biodegradable, compostable? Are they natural, vegan, clean, healthy, non-toxic? I'm going to give an overview on categories of textile biomaterials and some of the processes the industry works with, try to shine some light on the stage of development we're currently in, and introduce you to some companies and materials. I'm also going to talk a little bit about the research I do with colleagues and students at FIT. I'm going to focus on companies that really drive research forward and create truly innovative materials and processes. Those are the players that aim for large-scale production and true usability of the material, because you have to take into account that in terms of functionality, durability, water resistance, haptics, color, surface design. There is a very high standard. Conventional materials we've been working with for millennia, natural fibers, leather, for example, to achieve the same characteristics with the new emerging material. And there are many experimental and more art-focused examples out there. They're all valid in their own right, but they often do not provide a new angle or are not viable for real-world use. Many of them can be considered a proof of concept or an art project or a design object, but I'm going to focus much more on more advanced research here. One distinction you might see already on the screen here is between fabric-like or real fiber materials and then more leather-like or sheet materials. That's something we'll come to a bit later too with looking at some examples. Now, talking about a few of the companies on here, Milo is a company that produces a leather-like material based on mushroom mycelium. This is really one of the big players at the moment. Pinotex is based on pineapple fiber. At the moment, as far as I know, Pinotex is not yet fully biodegradable because there is a coating on the material. Kelson is an algae-based fiber that currently is not on the market as 100% pure fiber, but is used as a drop-in to other more conventional fibers. Senrive is made with Biofabrica Biotex. That's a material based on 100% plant-based proteins and a bio-PU, a polyurethane. So that's very, very promising, and we see the first prototypes out there that are already on the market. Tomtex is made of seafood shell waste and coffee grounds, and I think also contains some clay. Claims to have the same durability and characteristics as leather, but I'm a little cautious of that claim, and I haven't really looked at the material myself. So there is really one thing to take into account is there are strategies to regulate the hydration state and the subsequent mechanical properties of biopolymers, because there is always a danger they're drying out and becoming very brittle. So they meet the design criteria for textile applications. That includes tensile strength and ductility, but that often involves heavy metals and synthetic plasticizers, which compromise the material biodegradability and introduce human and ecotoxicity. So let's look a little bit at what biomaterials actually are and break this down a bit. The terms we're talking about now are often adapted from the biomedical field, and we can assume that they will evolve over time as this research moves forward. Pretty much everything falls under the all-encompassing but least specific term of biomaterial. All biomaterials are bio-based, but the bio-content can vary radically from less than 10% to 100%. So what bio-based materials are is they're wholly or partly derived from biomass, such as plants, trees, or animals, but excluding those that are derived from fossil sources. I want to be clear about that. The biomass can have undergone physical, chemical, or biological treatment. So examples include, but are not limited to, natural fibers, for example, cotton or wool or silk, man-made cellulosics, for example, viscose or rayon, natural polymers, which are, for example, chitin, which you find in the shells of insects, keratin, which is in our hair, casein, which is milk-based, animal leathers, or their alternatives, so the microbially grown leather alternatives, for example, and even polycotton blends, where the bio-content meets the minimum stipulated requirement to be called a biomaterial. Now, biofabricated materials are produced by living cells. So that can be mammalian cells, or it can be microorganisms such as bacteria, yeast, or a mycelium. But let's break that down a little bit more and look at biofabricated ingredients. Those are the building blocks produced by living cells and microorganisms, for example, complex proteins like silk or collagen. They need further mechanical or chemical processing in order to make a macro scale material structure, like a fabric or a leather-like material. Examples include fermented recombinant silk, which then has to be spun into a fiber or processed to form a sheet material. And I'm gonna show you examples of that, because right now we're all talking theory and it's probably a bit hard to follow on that. Biosynthetic materials are synthetic polymer materials comprised in whole or in part of bio-derived compounds. These compounds can either be made on the basis of biomass and or be made in a process that is performed by a living microorganism. In the natural world, biosynthesis is occurring all the time, everywhere. It describes the production of complex chemical compounds from simpler molecules. That this happens, for example, inside the cells of living organisms such as bacteria, plants, and animals. When a spider makes spider silk, that is pretty much a biosynthetic material too. The compounds resulting from biosynthesis can be either synthetic or natural. I know that's a little bit confusing to talk about a natural biosynthetic material in the context here of textiles, but it means that the process can either create a synthetic polymer that is chemically similar or identical to, for example, polyester, or it may be used to produce a natural polymer like cellulose or silk. Now, all of these materials aren't necessarily biodegradable, though a lot of them are, but part of their production, like growing the crops such as sugarcane or corn, or wheat or grass, that is used as the biomass to produce them, absorbs CO2 from the environment, and they can often be recycled. However, there are concerns that that many of these fibers or the textile materials made from them will be a mix of biodegradable and non-biodegradable materials. So for example, if the algae fiber I talked in the earlier slide is mixed with a conventional polyester, we have a mixed material that is partly natural biosynthetic materials and a synthetic one. And that really has a big impact on how compostable or biodegradable that material would be. And then separating them before composting will be really difficult. There are also often concerns about the use of genetically modified corn, for example, as a source, and of course the use of food products for the creation of these materials that are not for food. Now, I want to show you an example of a biofabricated biosynthetic ingredient. So, and this is a material called microsilk by Bolt Threads that is based on spider silk. So spiders produce silk fibers with remarkable properties, including a very high tensile strength, elasticity, durability, and softness. And Bolt Threads developed a technology to sustainably replicate this process at a large scale. There has for millennia been the actual spider silk. It's a very niche product, and it can be produced really by actually reeling the silk that spiders produce off the spider, putting it into a little harness, and then when it's extracting the filament, rolling that up. The biggest problem here is that spiders are very hungry and they're cannibalistic. So having a spider farm and not having enough for those spiders to feed, they will start eating each other. And that was the end of your spider farm. And then, of course, also extremely labor consuming to actually have a single filament yarn harvested from an insect. So what Bolt Threads worked on is producing these fibers based on the main input of sugar from corn. And the process they use is they use a genetically modified yeast to produce that protein after the fermentation is complete. So you have to really think about this like a brewery. The silk protein is then purified from the yeast, and the remaining yeast cells are destroyed by heat. So it's the same process that you would use to pasteurize milk. So none of these genetically modified yeast cells are in the final product or getting out into the environment. And this is also a process that has been used for a long time. Genetically engineered organisms fermenting products like insulin or vaccines, and this is a very established, safe process. The isolated silk protein is then turned into a powder, and that is pure synthetic spider silk protein, so that is exactly the same as what a spider would produce. And at the moment, it's only a polymer, so it's the equivalent of a polyester pellet, and it is then dissolved into a liquid and extruded to make a fiber. And microsilk is, so what you see here is a prototype with Stella McCartney. She is actually supporting a lot of this research, especially into vegan products. And they have actually created a different product, a knitted tie, as a prototype that I believe 50 of them were produced and sold. So it's still in a prototyping, not in the general market stage, but we're getting there. Another example I want to show you of a biofabricated ingredient is a company that is using E. coli to produce indigo. So natural indigo is based on a plant. There's a natural fermentation process to get to the dye stuff in it. It's very expensive to produce, it's very labor intensive. So the vast majority of indigo used is synthetic, and that is usually made from petroleum derived aniline in a high temperature, so very energy consuming process that also involves formaldehyde and cyanide. What this company, Hue, is doing is they're using a microbial fermentation process instead. So they examined the enzymes in the indigo plant that produce the natural dye and then duplicated them using biotechnology. And so the first dye they're working on is indigo. And they use Escherichia coli, E. coli bacteria to make the dye, which are also very commonly used for processes like this. So again, very safe, established process that has nothing to do with the E. coli that you might know from food-borne illness outbreaks. Okay, I have a short video I want to show you that talks about this process.
Color is everywhere, all around us, infused into the products that we're using and consuming every day. Today, conventional dyes and pigments are made primarily from fossil fuels in an extremely carbon-intensive process and requires a lot of toxic chemicals and heavy metals to produce. Our mission as a company is to use biotechnology to create more sustainable sources of dyes and pigments.
I was always interested in how the natural world worked. When I was an undergrad, I first became interested in this field of microbial engineering, how bacteria worked, how natural systems worked, how plants worked, and how to really manipulate cells to make novel and interesting compounds. During grad school, the first thing I did in the lab was to look into how plants made indigo and find this critical enzyme that was necessary for the production of indigo, and then engineer microbes to produce this enzyme and make indigo themselves.
I met Tammy through my partner, Andrew. He is also a bioengineer, and they were in the same lab together. So we got the chance to kind of form a friendship. My parents were entrepreneurs, and they had their own suite of apparel brands. Growing up, what sticks out the most is traveling to China to textile facilities and seeing firsthand some of the impacts of the fashion industry. Because of some of the things that I had witnessed, I actually never expected to start a company or work in fashion. It was really just sort of having the opportunity to bring Tammy's technology into the world. There was always sort of a part of me that wanted to believe that you could have good business and still create positive impact for the planet.
Indigo is such an iconic dye. We really can't make denim with any other blue dye because of the way that the indigo molecule kind of bonds to the fabric. Indigo has traditionally come from an indigo plant, where people can grow up the plant and then harvest it to use in dyeing applications. But that was really water intensive and land intensive and very labor intensive. Synthetic indigo is really what's used in almost all of the denim produced today. It uses petroleum as a starting point and a lot of toxic chemicals as intermediates. The process itself is also pretty damaging for worker health. The synthetic indigo industry is notoriously secretive, but we know that to make 1 kilogram of indigo dye, gallons of petroleum are needed. What we do at Hue is we go into these natural systems and organisms, look into what kinds of enzymes are responsible for making these dye molecules. And then we take those enzymes and engineer our bacteria to also express these enzymes and thus produce these dye compounds as well. We figure out the best conditions to grow them in so that they are producing the dye molecule efficiently. Then we also extract out the dye molecule and turn it into a powder or whatever final form the dye should be in to be a drop-in replacement for the dye industry.
I think the fashion industry is hungry for change. Brands are being held responsible by more conscious consumers. Garment recycling and circularity is the future, and an important precursor to that is making sure that we have clean, sustainable ingredients and inputs like dyes that are going into that circular supply chain. The potential of a bio-based solution like this is huge. It is both the kind of workers and the people in the communities for whom this is really going to make a difference. My name is Michelle Zhu, and I am the CEO and co-founder of Hue.
My name is Tammy Sue, and I am a co-founder and the CSO of Hue.
Okay, so just to bring this a bit of context for textiles, you see on the right side here in blue, these are the materials we're talking about, and they all fall under a category of man-made as opposed to natural materials. So actually they should be called woman-made, human-made, because there are a lot of women are driving this research. And you can see that but again, the difference here between the natural polymers and the synthetic polymers split up here into the base materials that are being worked with. So coming back to our overview here, that dark brown small circle is another part of the biofabricated materials, the bioassembled materials. And that is a material with the macro scale structure that has been grown directly by living microorganisms, such as a mycelium or bacteria. So that can be, for example, the microbial cellulose leather alternative. Now, as an example, I'm showing you here Milo-based prototypes, and I point that out as prototypes because I think other than the wallet or card holder, none of these products are out on the market yet. But they pretty advanced in terms of industry partnerships and prototype examples that are very finished. So I think we'll be seeing more of that material out in the market soon. And Milo is based on Mycelium. So Mycelium is the root-like structure of a fungus consisting of a mass of branching thread-like hyphae. So the fruiting body, the mushroom as we know it on top, that is just really, as I said, the fruiting body. The whole body of the fungus itself is the mycelium that is usually underground, can also be in wood. And that is really the system that digests food materials, cellulose materials, to create their biomass. And there is a huge mycelium in North America that is actually the biggest living organism on Earth that goes over hundreds of square miles. How is Milo made? So this process begins with the mycelium cells growing on the renewable organic substrate. So that can be wood chips, it can be rice hulls, it can be coffee grounds. And the mycelium forms a densely interconnected network of what is initially a soft foam that can be then harvested to make this leather-like material. So what Milo very likely works with is heat processing and pressure. And then they also work with some tanning processes with a company. So as far as I know, the Milo material itself is created with 85% mycelium from fungi and 15% of lyocell. That is a regenerated cellulose fiber. So that is made from wood chips that are broken down into a pulp and then spun, and then finished with a water-based polyurethane that enhances its durability. So you can see it's a multi-layer material. The PU coating would be there to give it the same water resistance and surface texture as a more conventional leather. And that is what it looks like when it's grown in a lab. So you see these trays grow the mycelium that is then harvested for processing. Now, I'm adding this slide here. This is another overview of what I just talked you through, maybe a little bit easier to read because it has more of that information. than the one with the round circle. So if you want to come back to this, so pause it here, it gives you a little bit more time to understand this. So I think the important part is really here, biomaterial, the umbrella term doesn't tell us very much. Bio-based is really what we're looking at here. And then we have the biofabricated materials, and those have an overlap potentially with the biosynthetic ones. So not that this is always that easy to determine, because there is that overlap, but I think knowing that gives you a better understanding of how these materials are made and what you're actually looking at in terms of the production process and origin when you look at one of those leather-like materials. In terms of availability and the research, so why can't you get your hands on most of this stuff yet? That is because even with the most advanced ones, I think we are probably at stage 8 right now. A lot of the research hovers somewhere around stage 4 or 5. So it really starts with an idea, very basic research into materials, literature research, then first formulations, and very small prototypes. That process alone can take years. When the first prototypes are established, larger scale prototypes can be made, and then that moves into maybe doing, working with more lab equipment, producing a larger amount, so testing can be easier. And that is really where money needs to come in to fund the research. And ideally, of course, once the full commercial application, the step 9 is achieved, it can be upscaled, and a product can be produced in enough amount to really be useful in the textile industry, and also with characteristics that are always reliably the same, so there's a consistency in the product. Now, if we look at some of these companies out there, so we've for example, talked about bolt threads, the third one down. They are very advanced with their research, and they have partners, big name partners that put funding on. MycoWorks is also working with Mycelium, and if you look at, they had 125 million in financing in 2022. So we can expect there to be commercial applications coming out pretty soon. Modern Meadow was also one of the first companies really jumping into this and creating biopolymers based on protein and actually also on collagen. And they, at the moment, have moved into the cosmetics industry, actually, producing collagen for cosmetics with the microbial production. But they still working on the textiles with Biofabrica. And I think that a lot of the cosmetics research is actually funding the research into textiles. And then the last one, for example, that I added is Wearwool in New York City. That was a company started by FIT students and a colleague of mine, Thian Shiros, that's working on engineered biodegradable protein fibers with inherent color and function. So, for example, using some genetic coding from coral that give it a bright red color that can be built into the fiber. And they just received almost 4 million in seed funding. Now, I want to talk a little bit here about the research I'm doing at FIT, which on one hand is happening in the classroom. So I teach a class, Designing with Emerging Materials, which is an interdisciplinary textile design and science class with my colleague, Thian Shiros, which you see here in the photo, who's at FIT and also Columbia University, with whom I collaborate on all things biofabrication, because I am not a scientist, I'm a designer. So it really, and that is a very symbiotic relationship we have here working on it together. both understanding the science and being able to apply techniques from the textile industry and applications that relate to textiles and fashion. In the classroom, the class we teach is really an introductory class. So we want to introduce students to the research process, to understanding what materials there are, how they can use them, how they can work with them. And what we really have for the final research project is only about 5 weeks. So this semester we had some students working on a halochromic ink that reacts to acid, and their idea was to add it to food packaging to see if the pH value of the contents have changed, which can be an indicator that food has gone off, or those indicators are also used in wound care because wounds change their pH values in healing. And they developed a soy protein based printable ink that reacts to pH changes. We had another group that was looking at mushroom enzymes to break up synthetic dyes. So it could be dye remediation that could help with composting cotton, but could also replace some dye processes in the industry. Oh, and we had another group making embellishments, sequins, and beads out of bioplastics. So just some examples of what we're looking at. The research project we're working on at the moment, the most, my colleague and I, is looking at the biosynthesis of nanocellulose. So the picture you see here is a Cetobacter bacteria spinning nanocellulose fibers. Those are the little lines you see in here. And what we're doing with that is creating a leather-like material, which is a bioassembled material because it's a macro structure that is grown directly by the bacteria. So what we're using is actually what's called a SCOBY. That is a symbiotic colony of yeast and bacteria. You might know that as kombucha. So it's been used for millennia in creating a fermented food product, and the byproduct of that process is really that leather-like that nanocellulose we're using. The SCOBY, that symbiotic colony, creates this as a byproduct of breaking down of fermenting sugar, and it creates its own surface to live on. So the float is floating on the surface of this mix of sugar and tea that the bacteria digest, and it builds its own raft that protects it from UV light, that keeps it hydrated, and that keeps it afloat with access to oxygen. We have tailored that process to grow it in shape and developed a processing process that is based on indigenous leather tanning that was usually done traditionally with brains, but we turned that into a plant-based process that gives the material a real leather-like feel. Otherwise, it gets very dry and brittle. With this process, it has a subtleness of leather and a lot more water resistance, and is also very flame retardant. And the beauty of it is that it is fully biodegradable, and that means it can also go back after composting as a soil nutrient and help to grow food, and then the byproduct of that can be converted into sugar and then can be used again for the biosynthesis. One of the first prototypes we did were these bags. You can see a close-up here. And then we also looked into surface and color design, because the natural color of the microbial nanocellulose is is kind of a rustic brown, and that has its applications, but in a design context, it gets a little bit tiring after a while. So we really looked at a lot of natural dyes to either add to the growth liquid right from the start, or purify the cellulose and then dye it or apply it with a mordant dye process, or and we've tried embossing, which works really well, and we've also developed a soy-based ink that holds very well on the material, is fully biodegradable, and that we can mix with natural pigments. So a few more examples here. This was a prototype Thean Shiras has done with public school to create these sneakers. And currently we're working on a custom lab-grown suit with Suited Atelier. So Ash Owens, the owner of Suited Atelier, does bespoke suits. Our colleague Amy Sperber works with 3D modeling software called Clo for zero-waste design. So we're really using all of the material. And we developed some green screen printing processes that hold up very well on the tanned microbial leather, for example, with the soy protein binder or iron and tannin mordants. And at the moment, we're pretty happy with the material. So we really achieved something that has a much more textile-like look and feel to it, even mimicking some of traditional suiting fabric, woven textures. And we hope to have to finish the suit by the end of the year. I want to say we might need to grow some more material, but keep your eyes out for it. It'll be out there at some point. Some resources that you can dive into to learn more or come back to. A lot of the material in this presentation was based on this, is a paper in Environmental Science that I'm a co-author for, about microbial nanocellulose biotextiles, that talks more about the growing process and the tanning. And then also a very good report published last year by Biofabricate and Fashion for Good about understanding biomaterial innovations, very focused on the fashion industry, but really a good guideline to asking the right questions. So I hope I was able to shine a bit of light on all the exciting news you might be hearing about new materials out there. And I'm very excited about where these developments are going. I think we can expect in the next few years to have a few really big breakthroughs.
Thank you, Susanne. That was really great, really confusing. There's just so many different options, so many different processes, so many different considerations. Somebody posted and you responded to them that, everything right now is being branded as vegan. And, and while it may be based on plants, the processes to make them into something that's usable are not always as environmentally wonderful as the word vegan would lead you to believe. So what do you and your students look for in evaluating which of these different approaches are things that you want to look at and to invest time into exploring?
So first of all, we're really looking at the sustainability aspect, and we really want to create materials that are fully biodegradable and have the least possible impact. So we work a lot with life cycle analysis as well. And one thing I want to point out, this is a very fast moving area at the moment, because when did CRISPR really become available? The tool that allows us to do gene editing at a much lower cost and faster turnaround. And that really enables a lot of the modified organisms, like using yeast or bacteria to produce these ingredients, and doing that on a level where you can do that even without having access to a super equipped lab. So that there we will see a lot of change in the future, because the research is hot right now. A lot of people are working on it. And I think with some of the early adopters, companies like Modern Meadow, for example, they at a point now where they're really starting to scale up. So I wish I could predict the future, but I think we really need to keep our eyes open, and I hope we'll see these materials in the market soon.
Well, I've got another predict the future question for you. So I've always been, I should only wear cotton that's a natural fiber, and it's, it breathes, it's a great fiber. But as I become more educated about it, I realize that cotton uses more pesticides and fertilizers and all sorts of terrible things than probably anything else that the United States grows. So do you think that in the future we would no longer have cotton being produced, but instead it would all be mushrooms and algae?
No, because I at the moment I cannot see them feel like cotton. I mean, this is kind of the conundrum we are with in the industry, and my advice is always use things as long as you can. If you pause the whole life cycle at the use stage, that is going to make the biggest impact. And just buy consciously, and wear the things you buy. A big problem we have in the industry right now, that people buy a lot of clothing that they actually not wearing, or wearing 1 or 2 times. So there's this very disposable fashion sense, if we can move away from that. But of course, that's driven by psychology, by capitalism, by politics. And but for ourselves, keep things for a long time, that will make a big impact.
Luana Rubin was posting about how she hopes that eventually luxury cars will have upholstery that's not made from animal leather. And, that's another component to trying to decide which products to purchase, to use, is your feelings about the industries that produce them. And somebody asked about carbon footprint. And would you say that that's mostly what these researchers are trying to reduce, is their carbon footprint?
Well, so just coming back to the car,
okay.
The car leather was really interesting with the tanning process we developed and patented, is that the microbial nanocellulose is very flame resistant to a very high temperature. And that makes it a very interesting material for interior purposes and car or airplane seats. So that's definitely something we keep in mind. At the moment, we're not quite there yet with it holding up long enough and having the same characteristics. But that will be a big impact. And then with the carbon footprint, the exciting thing about biofabrication, for example, is that it can be done almost everywhere. It's not that hard to keep yeast happy. I mean, to make these things, you want to keep it.
They're in my refrigerator.
Yeah, but that means these micro factories could actually be set up where they need it, and that means material wouldn't have to be shipped around the world. And if we look at, for example, the amount of food waste we have in the US, if some of that can actually be diverted to create the biomass, the sugars to feed those bio factories, we have a very local setup.
And that's a really interesting point, is by eliminating transportation, it really changes the whole dynamic, being able to process all of that waste food. I know when my kids were in school, there were various composting programs, and the amount of compostable food coming out of an elementary school cafeteria is mind-boggling. So that does sound very interesting. The research being done into alternatives for the petroleum-based dyes does sound really interesting also. Having done a lot of fiber reactive dyes with the Procyon dyes, you know, I'm committed, but I do realize that there are a lot of problems with disposal, wastewater, et cetera, especially if you're doing it on a much larger scale than I'm doing in my home. So that also is really interesting. I guess my last question for you is, as a person in the world without a lab, having no desire to create a lab in my kitchen, how would you advise me to evaluate the different products that are being used so that I can do the least harm in my purchasing?
So a lot of the materials I talked about today are not really available yet.
Right.
You might get a small prototype product, or there are samples that are being circulated in the industry, but it'll be a while until they become available. It can be difficult to find that out, because a lot of the companies keep the proprietary information secret. I think what's really important is a company, is the transparency. For example, Milo, working with Stella McCartney, they're really trying to be transparent, and they say this material is made out of 85% of the mycelium, and then there is a coating.
Mm-hmm.
And at the moment, the idea is it's at least 85% less of a non-biodegradable material. And we're working towards, everybody in this field is working towards better solutions.
Mm-hmm.
But for now, it's maybe not the best solution, but it's a little bit better than what there was before.
Mm-hmm. Well, that's a great answer. Thank you. Thank you so much for sharing with us, even if it's a little overwhelming to look at all the different options. It does help to understand a little bit more about where the research is coming from, where we're headed, and it certainly will be interesting to see how things develop as you know the news reports it, and we follow along. So thank you very much, Susanne. I really appreciate your time and your expertise. And if you really want to go learn more, look into Fashion Institute of Technology and taking Suzanne's course for her students. If you've enjoyed today's Textile Talk, I hope you will consider making a donation. Putting on the Textile Talks throughout the year costs a little over $50,000, and we need your support to be able to continue to bring you this kind of programming. Again, I want to invite everybody to go to SAQA.com/artinplace, one word, and to join us for a mini conference July 14th and 15th. And I hope you will join Textile Talks next week. Surface Design Association is going to be sharing highlights from their new exhibition called Safekeeping. And the week after, June 28th, I'll be back again with the National Basketry Organization, and we'll be talking about our collaboration on the traveling exhibition, Art Evolved Intertwined. I hope that you will join us then. Have a wonderful day. Susanne, thank you again.
Thanks for having me. Bye, everybody.